Hi students. Here we go. Lesson 76. Our first lesson for the week has two topics. Pardon my shadows. I know this is a little bit dark. I'm trying a new recording studio, so hopefully this will work. Our first topic involves systems of equations, and in this variation on the theme, we're going to use both substitution, I spelled that wrong, oops, and elimination in the same problem to solve our systems of equations. And then we're going to talk about negative vectors. We'll switch over to trigonometry. Okay, so first we have some pure algebra coming at us, and then we'll do some trig. All right, let's talk about the substitution and elimination problems first. Here's what's going to be different about them. We're used to seeing systems that look like this. Oh wait, this is super simple. This is x equals 2y, and then we have x plus y plus z equals 9. Now right off the bat, we haven't even finished setting up this problem, and you can see a wrinkle. We've got three variables. We've got an x and a y in the first equation, but we've got an x and a y and a z in the third equation. So we know right away that we're in deeper water. The next part of the problem looks like this. X minus 3y minus 2z, that's a 2z, equals negative 8. And we can see this is good news because we have three variables, so that means we need three equations in order to make this work. By the way, this is 76.1 on my page 316. So, three variables, three systems of equation. What the heck? The question is, how do we solve this? So, as you can see up here, our strategy is going to be to use substitution and then elimination. Now, I'll start right off the bat telling you guys that there are many different ways to use substitution and elimination as tools to solve this problem. There isn't just one way, and that used to confuse me because I could never understand why the teacher picked the way that he did to start solving it. And what I'm going to tell you is that it doesn't really matter. You can use substitution all the way through. You could try eliminating all the way through. It would work. The issue that we're going to do is we're going to follow it the way the book does so that you get used to kind of flipping back and forth between the two. So the first step that we're going to do is we're going to substitute. Oh, and by the way, let me do this. They put these letters down here these are not variables. These are just names for each equation so you can talk about them. We see that equation A is a simple equality. We see that equation B uses the same variable that one's set up for. So we're going to start by moving this 2y into the place of that x. Okay? So we're going to rewrite equation B and call it equation D by saying 2y plus z equals 9. So there we used substitution. Okay, so now we have this new equation D, and then what we're going to do is we're going to also substitute equation A into equation C. Yes, I did say that right. So now we'll have, okay, so this one's ready to go. So now we'll go 2y, substituting our 2y in for our x, minus 3y minus 2z equals 9, straight substitution. And now we can combine like terms, so we'll get negative y minus 2z equals 9. This we're going to give a new name to. That's equation E. Okay, so the letters are just helping us refer to them. All we've done is we've taken this first equation and substituted it in to both of the other two original equations. Now what we can do is we can eliminate, moving over and using our second strategy. We're now going to eliminate equations D and E against each other. So I'm just going to rewrite them. Oh wait, I forgot to combine like terms there. Squiggle that out. Let's start over. That would be 3y, yeah? So we've got 3y plus z equals 9, and minus y minus 2z equals wait, I copied some numbers wrong here. This one should be minus 8, right? That should have been a minus 8. My bad. That's one thing about, weird thing about doing it on videos is you guys aren't here to help me catch my mistakes. So hopefully I won't make too many more. But our second equation then becomes the minus 8. Okay. So, again, I'm following in the book. Even though we choose to eliminate, there are many different ways you could do that. You could, well, not many, but there are two. You could eliminate the y's or you could eliminate the z's. What the book chooses to do that we will follow along is they multiply the first equation, d. They're going to multiply that one by 2. And then they're going to leave the second one as it is. So I'm going to, that's a 2, not a z. So I'm going to rewrite again. Here's my pair. Here's my pair, just to keep everything clear. Now we've got 6y plus 3z equals 18. Don't forget to do it to both sides and all terms. 6y plus, 2z. Ooh, see, it caught that one too, didn't I? 2z equals 18. And then this other equation stays the same, but you can see what we did. Whoops, that's a minus. Equals minus 8. So these guys are the offsetting pair. We add them, we get 5y equals, and notice this all cancels out, 18 minus 8 is 10. Divide them both. Oh, look what I did. 5, we get y equals 2. So there's the first part of our answer. Not so horrible. Move it up so you can see it. See my squiggles out there? Okay. So now that we've solved y for 2, we can go back and easily use that information. I'm not even going to rewrite it. If y is equal to 2, then through this equation, we know that 2 times 2 will equal x, so this gives us x is equal to 4. And then if we plug all of them into this equation, we would get 4 plus 2 plus, I'll make that a clearer 2, z equals 9. That's 6. So then we get z equals 3. Okay? So the tricky thing here is just using the tools of substitution and elimination to manipulate your equations. Again, there isn't just one way to do it, so don't feel frustrated if you thought of a different way. Just know that the book is walking you through the process, and once you get the hang of these, you can use whatever strategy you like. What I would like you to do now is turn to 76.2, which is at the top of page 317. And there it is. I'd like you guys to work that one together, and I'm going to write them down so you can see them. 2x plus 2y minus z equals 12. 3x minus y plus 2z equals 21. And x minus 3z equals 0. Again, there's many ways you could do this. There's not one right way, but my eyes go immediately to this problem. X minus 3z equals 0. I want to substitute to that to x equals 3z by swimming the 3z over. Now I'm going to replace this for the x values in those two equations and start with that substitution and then go to elimination. So try that strategy and give that problem a try. Go ahead and pause me while you do that. Okay, now that you're back, congratulations on completing that, by the way. I'm sure you did brilliantly. Let's talk about negative vectors. So we're switching our brains over to trig mode. And, oh wait, let's do this. Let's cross that out because that's so rewarding to be done. But I'm going to get rid of that paper now. Okay, so we have talked about vectors, and we've talked about polar coordinates, and we have explored the idea that if we've got a point, say our point is here, we can, and let's say it's 10 units out, we can name that point. We know it's going to be 10 on the outside, and then we have to figure out the degrees. And let's say this is what? Let's make something up, 30 degrees here. So we can name this polar coordinate either by adding this way and saying it's 90 plus 90 is 180 plus another 30 is 210. Or we can name this by using negative coordinates, which is to measure in the opposite direction. We'd have 90 and then we'd have another 60, so that would be minus 150 degrees. Notice that if you've got two names for the same point, those two should always add to 360. So you know you've got every degree accounted for. So we can use negative signs to indicate either a positive angle or a negative angle as we're measuring them. But here, let's make it even more confusing. We can also change the magnitude to use negative numbers. And let me show you how that works. Here's an example. 76.3. So what they want us to do is they want us to add minus 4 to the minus 20 degrees plus 5 to the 135. Now notice how confusing this is because we've got two negatives and two positives. So we have to keep our brains sorted out. So let's start with the first one. Draw our grid. We always do the angles first. It's negative 20 degrees. So we start on the right horizon and we go down just a mere 20 degrees. Block it off. There's our angle. And I'm going to draw my right angle and our magnitude. Wait a minute. Our magnitude is negative 4. So guess what, you guys? This is the way you do it. The negative 4 means that when you've measured out that angle here, you actually take it in the opposite direction. So I'm going to dot it just so you can see. See how I'm taking this? This would now be 20 degrees this way. And our point lies 4 units out on this line. That's how we measured the negative 4. Okay? So we measured the negative 20 degrees by going down, but we measure the negative 4 by going 4 units in the opposite direction. And I'll label that. Okay? Weird stuff, isn't it? So now we measure 4 degrees out, or 4 units out. We have our 20 degree marker there. I'll drop down my right angle. Let's pretend that's where our 4 comes out, just to make it neat and clean. Now we've got our triangle, and we can go ahead and find our the lengths of A and B. So A is opposite, so we know that that is always going to be the sign. So we use, and we can use the shorthand of this, A equals 4 times the sine of 20 degrees. Remember, sine is always to find the opposite side, and to find the adjacent, we use the hypotenuse times the cosine of 20 degrees. If you run those through your calculator, you'll get, and we're taking these to several digits, we'll take this one is 1.368, and this one is 3.7588. So that gives us our points. We know that it is let's see, I'll write it up here. It is negative 3.758 to the right plus 1.368 up. Okay? And now we're ready to do the second picture. So let me slide my page just a little bit. This is where we're going to add up our total. So we can, because remember, we're adding these two angles. Here's the first angle. We found the two coordinates, and we write that in the rectangular coordinate style so that we're ready to add the second angle in here and finish it off. So now let's look at our second angle. Draw ourselves a grid. This one is all in positive, so now we have to switch our brains over to the other mode. We want to go 135 degrees in the positive direction, so there's 90, and there's, let's see, the whole thing will be 180, so we only need, what, 45 of these, right? And our magnitude is in a positive direction, so we're not going to go backwards. If we were going negative, we'd go this way, but we're going positive. So we go this way, and we go a total of 5 units. So I'm going to call that 5. Drop it down. There's my angle. This, we know, remember we had to add to 135, so we know that we've got 90 here, and we've got 45 in this part of the angle. And so this dude must also be 45 degrees. All right? So we use our same process. Let's just name these C and D. I like to put letters on them. Just helps me keep it straight. C is the opposite, so that is the one that's affiliated with sine. So we use our hypotenuse times the sine of 45 degrees. And we use D equals 5 times the cosine of 45 degrees. Run them through our calculators, and we get 3.5355. And for this one we get, oh, it's the same thing, which always happens with 45-degree angles. Your sine and your cosine will be the same because these angles are equal. And now we can put them up here. Notice that this C, no, let's see, it's our D value is negative. C is positive, D is negative. Just like here, our B is the negative. So that is our right measure. So this goes minus 3.5355 to the right plus 3.5355 up. Beautiful. So now we've got both of our angles expressed in rectangular coordinates, and now all we have to do is add them. 8 plus 5 is 13. 8 plus 5 is 13 plus 1 more is 14. 1 and 5 and 3 is 9. 7 and 5 is 2. Carry the 1. Did I get it? Yes. And that is negative, remember, which makes sense because both of the angles are in this quadrant, so it makes sense that we're going to have a negative and then a positive. So that's negative 7.2943 to the right. And then let's add our up. Let's make sure we add a 0 here because this has one fewer decimal. 5, 3, 0, 9, 4. Yes. And that is positive up. Okay? So that is what I get for our final answer. When I compare it to the book, I see that they've rounded, and their answer is minus 7.29 to the right plus 4.90 up. So that is what Saxon has. It's certainly verified by our answer. I didn't round it all the way down. Oh, I didn't let you see that. I'm really sorry, you guys. Now you can see all the numbers that I was adding. Okay, what's new here is the idea of measuring the magnitudes in the opposite direction when they have the negative sign. All the rest of this, hopefully, is review and additional learning. There is not an example problem for this, so I would suggest that you do practice problem B together as a review problem in order to practice negative vectors. Good luck, you guys. That is a really hairy calculation, but I hope it's starting to get more comfortable. If it is not getting comfortable to you guys, if you're still confused on this, somebody email me, call me, text me, do something, and we can talk about it. All right? Good luck.